Right, so we're up and running now with the C grade questions that are on the paper. Question 11. Stephen and Gwen play a game using 4 discs with a positive whole number on each disc. The discs are placed in a bag. Stephen selects a disc from the bag at random. He writes down the number on the disc and puts the disc back in the bag. Gwen now does the same, and they then add together the 2 numbers they obtained. If the numbers add up to give an even number, then Stephen wins, otherwise Gwen wins. The numbers on the discs are 1, 3, 5, 6. Who is more likely to win this game? Give full details of your reasoning. Now, any probability game, it's usually easiest to see what's happening if you draw a sample space diagram. And what one of those are, sometimes in some questions they're given to you, is where you can work out what all the possible outcomes for the game would be. So in this case, if we've got Stephen's turn there and Gwen's turn there, these are the possible numbers that Stephen can pull out. They get put back in, and then Gwen pulls out the same numbers. So it's possible that they could both pull 1 and 1, which would be 2 because they're added together. It could be 1 and 3, which is 4, 5, 7, sorry, 6, 2, 4, 6, 7. This one could be 4, 6, 8, 9, 6, 8, 10, 11, 7, 9, 11, 12. Even, if it adds up to an even number, then Stephen wins, otherwise Gwen wins. Who is more likely to win? So the probability of even, so if I circle the evens, so the probability of even out of a total of 1, 2, 3, 4 by 4, so it's 16 possible outcomes, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those are even numbers, so the probability of odd will be 6 out of 16. So the most likely winner is Stephen because there are more evens. Okay, and you've shown that by writing the probabilities. Numbers on the discs are changed as shown below. So with the first one you had 3 odds, 1 even. This time you've got 3 evens, 1 odd. So we do the same thing again to see what effect that has. Excuse me. So 1, 2, 4, 6. 1, 2, 4, 6. Stephen, Gwen. 2, 3, 5, 7. 3, 4, 6, 8. 5, 6, 8, 10. 7, 8, 10, 12. So again, if I now circle the evens, we'll see that it's still not a fair game, and Stephen is still most likely to win. So you've got 10 out of 16 there, and 6 out of 16 there, so still not fair. So if we've got we can see here, if the odd numbers outnumber the even, or the even numbers outnumber the odd, it's not going to be fair. So what we would want to try now for a fair game would be to have 2 evens and 2 odds. So if we went 1, 2, 3, 4, for example, so 2 times even, 2 times odd, and look at what happens this time. Two, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, 5, 6, 7, 8. So if we circle the evens now, two, 4, 6, 8 out of 16. So the probability of even is 8 out of 16. Probability of odd is 8 out of 16. And the rule for our choice is just the same number of odd numbers as even numbers. Okay, marks for that question. So we've got 1 mark for working a strategy out to solve the problem. So my strategy there was that diagram. 2 marks for working out what all the possible outcomes were, and then 1 mark for determining which one is most likely to win. And then for B, 1 mark for, again, a different way, a different calculation of the outcomes, and 1 mark for showing that it's still not fair. And then for part C, 1 mark for a choice of 2 evens and 2 odds, and 1 mark for explaining what you've done. Okay, question 12. Enlarge the rectangle shown by a scale factor of 2 using 2, 1 as the centre of enlargement. So first of all, you've got to find the point 2, 1, which is there. So because they're giving you a centre of enlargement, it means that you can't just drop that rectangle anywhere on the grid to enlarge it. You have to do it so that its distance from that point has also been increased by a scale factor of 2. So from that point, to get to that corner, we've got to go across 1 and up 2. So in the enlargement, we've got to go across 2 and up 4. 1, 2, 3, 4. So the enlarged rectangle is going to start there. Then we can enlarge it by a scale factor of 4. So this side is 2, so it's going to go up 1, 2, 3, 4. This side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to take you to there. So it's not enough just to enlarge, to draw a rectangle twice as big as that one. It also, for 2 marks, has to be in the correct position. And the correct position is from here to the original is 1, 2. So in the enlargement is twice as big, 2, 4. So for that question, you'd have 1 mark for an enlargement and 1 mark for having it in the correct position. For the rotation, this is where you'd be allowed to use tracing paper, and I would recommend that you do so. So what you do is, first of all, trace your shape, and next to the shape somewhere mark an arrow going up the page. Then read your rotation. So it's going through 180 degrees, so it's half a turn, about the point 1, 2. So that means that you have to pivot this tracing paper on the point across 1 up 2, which is there. And because it's a 180 degree turn, it doesn't matter which direction you turn, clockwise or anti-clockwise, but we want to keep turning until that arrow is pointing exactly down the page. So turning your tracing paper until the arrow is going down the page, and then you can see where the shape needs to go and put it in the right place. So it's going there, there, and there. So that's what you're looking for. 2 marks for that, 1 mark for a correct rotation, and 1 mark for having it around the right point. Okay, question 13, exchange rates. Use the exchange rates in the table to answer the following questions. Exchange £350 into Icelandic krona. So £1 buys that many Icelandic krona, so 350 lots of that is what you're able to buy. So we do 350 times 192.45, which is that many, which are going to be 67,357.5, and because we're working to 2 decimal places, we add the 0. How much money in pounds would be needed to buy 2608.32 Indian rupees? So this time now we're going from rupees into pounds, so we're not going to multiply by that quantity, we're going to do the opposite, which is dividing. So 2608.32 divided by 132, £26. Complete the sentence below. 100 Russian rubles are worth the same amount as blank Icelandic krona. So we have to work out an equivalent between the rubles and the krona, and what links them both are the pound. So if we first of all turn 100 rubles into pounds, so the 100, when we're turning into pounds, we're going to be dividing by 53.67. So we do 100 divided by 53.67, so that's 186. And then we need to turn that into Icelandic krona, so we now multiply our 186 by 192.45. So that equals 358.58. So 100 Russian rubles are worth the same amount as 358.58 krona. Marks for that question. 1 mark for multiplying, 1 mark for your answer, 1 mark for multiplying, 1 mark for your answer. For part C, the method there is to turn them into pounds first and then back again. So you get 1 mark for working with those values, and then 1 mark for the method and 1 mark for the answer. Question 14. Rowena owns a car that David is planning to buy in 3 years' time. Rowena's car is currently worth $3,500. Rowena estimates that her car will repeatedly depreciate by 24% of its value each year. David has already saved £100 and he wants to set up a savings account to save a fixed amount of money each month to buy the car in 3 years' time. What would be the minimum amount of money to the nearest pound that he should pay into his savings account each month? Okay, so the first thing that we need to do is to work out what Rowena's car will be worth at the end of 3 years. So in the first year, it will lose 24% of £3,000. 24%, write it as a decimal, pence in pounds, multiply by 3,500. So after 1 year, it's going to be worth $3,500 less 840. So 3,500 less 840, 2,660. So after 2 years, she's now going to lose 24% of that value, not of the 3,500. So she's going to lose another £638.40, which means the car will be worth 2,660 at the start of the year, less £638.40. Which is £2,021.60. So after 3 years, she's now going to lose 24% of that. So she's going to lose another £485.18. So the car is worth 2,021.60 less 485.18. £1,536.42, because the next digit is 5 or more. So that's how much David is going to be paying for the car. So he needs to save that much, less than £100 is already saved. £1,436.42, and he's going to save that in 3 years. So monthly payments would be 36 monthly saves. So 1,436.42 divided by 36. Let's take the 100 off that. Divide the answer by 36. He needs to be saving £39.90. To the nearest pound, £40 a month in order to be sure of making the saving. Part B, do you think the amount saved each month will guarantee that David will have enough money to buy Rowena's car? So when he's saving that money, he will be earning interest on it as well. So there will be more money in the account than he needs. So there are two things you could argue here. Yes, because he will also earn interest on his savings, so will end up with more money. But you could also argue that you don't know, because Rowena's only estimated a 24% fall on her value of the car. So you could argue no, because that could be too high or too low. Right, so marks for that question. So you've got 2 method marks for your method of 24% taking it off, 24% taking it off. An answer mark for getting down to 1536.42. 1 mark for taking off the £100 that he's already got saved. A method mark for dividing by 36, and an overall answer mark for your £40 a month. That comes to 6. Sorry, and an answer mark for rounding it to the nearest pound. And then you've got an explanation mark for how you explain the interest. Finally, a little bit of algebra to finish this question off, this paper off. So question 15, when you're expanding, what you need to do is multiply what's outside by everything that's inside. So we get a 5 times a 2, which is 10. A y times a y squared. When you multiply two algebraic parts together, which are the same base, y, you add the powers. So that's going to the power of 1. So y times y squared is the same as y times y times y, which is y cubed. Take away 5 3s are 15 y. Simplify. So again, this is an indices question. You can multiply the numbers together. 4 5s are 20, and y cubed, h cubed times h squared. H cubed is h times h times h. H squared is h times h. So you are multiplying h together 5 times. And then for this question, which is a particularly unusual question to see on a foundation tier paper, to find out what n is worth, you have to get rid of the times 2. When you get rid of the times 2, you've got to divide by 2. You have to divide the whole thing by 2, so you get 3 is less than n is less than 13 divided by 2, 7.5. It then asks you what all the integers, now integers mean whole values, so what whole numbers satisfy that. So this is saying any whole number which is greater than 3 and less than 7.5. So it's going to be 4, 5, 6 and 7. It's not 3 because it doesn't include 3, and it's not 8 because 8 is bigger than 7.5. So that is an unusual question to see on a foundation tier paper. 2 marks for that. 1 mark for the 10y cubed, 1 mark for the minus 15y. 1 mark for that, and for this there's a method mark for dividing throughout by 2, and then 2 marks for your list of integers. So quite an odd end to that paper.